So imagine you were tasked with building just an absolutely impenetrable bank vault.
Right, like a $1 billion state-of-the-art facility.
Exactly. I mean, you spend billions of dollars designing it. You install biometric scanners, foot-thick titanium doors, thermal sensors, laser grids, the works.
And obviously you test it relentlessly for years.
Oh, yeah, you test it constantly. And then, on opening day, you accidentally just tape the master blueprints, complete with the override codes, mind you, right to the front door for anyone walking by to read.
Well, on March 31st, 2026, Anthropic did essentially exactly that in the digital world.
Yeah.
And what's fascinating here is that it wasn't some sophisticated, highly coordinated nation-state cyber attack that exposed the inner workings of their flagship AI agent, Claude Code.
Right.
It was honestly a remarkably mundane typo.
Okay, let's unpack this.
Yeah.
Because we have a massive stack of incident reports, technical security disclosures, and business analyses covering the file out today.
It is a lot to get through.
It really is. We are looking at a $60 billion titan, a company known throughout the tech industry for its absolute dedication to AI safety, suddenly dealing with the biggest AI security incident of the year.
Yeah, without a doubt.
So our mission for this deep dive is to figure out how this level of exposure actually happens. We'll look at the hidden mechanics of the vulnerabilities researchers found in those leaked files and, what this all reveals about the alarming realities of giving AI agents access to our computers.
So to start, the genesis of this whole incident traces back to a very specific release.
Which one was it?
It was version 2.1.88 of the Anthropic Claude Code package on NPM.
Okay.
When developers at Anthropic prepare the software for the public registry, they run a build process. They take their original TypeScript source code, which is, human readable, and compress it down into minified JavaScript.
Right, minification. So that strips out all the spaces, shortens the variable names, that kind of...
Exactly. It basically turns the code into this dense, highly efficient block of text that runs faster.
But it's incredibly difficult for a human to actually sit down and decipher.
Right. But during that minification process, the build system also automatically generated a 59.8 megabyte source map file, which ends in .map.
Wait, a 59 megabyte text file?
Yeah.
For anyone who regularly works with raw code, a 59 megabyte text file is just staggeringly large.
It's massive.
So if I am reading the technical documentation correctly here, this source map functions essentially as a direct translation key, right?
Yes, it reverses the compression entirely. So think of it like this. If the minified code is a heavily redacted, tightly compressed book written in some dialect you barely understand, the source map is the original, fully unredacted English manuscript just tucked right into the back cover.
Oh, wow.
Yeah, it maps the compressed logic directly back to the original architecture.
Which makes sense for internal testing, right? You want your engineers to be able to read the errors they encounter in plain English.
Absolutely.
But how does an internal debugging tool like that just end up on the public internet?
Well, through a failure in basic deployment hygiene, honestly.
Really? Just a simple mistake?
Yeah. Developers use configuration files like .npminor to explicitly tell the deployment system which files to leave behind.
Okay.
And whoever managed that version 2.1.88 release just failed to configure that file to exclude the source map.
Wow.
So the public update went out with the internal translation key perfectly attached.
So a single omitted line in a configuration file basically bypasses all of their billion-dollar safety protocols.
Pretty much, yeah.
That is just wild. So when the security researcher, Chaofan Shou, discovered this file and posted about it on X, what exactly did that map lead to?
The source map pointed straight to an unobfuscated TypeScript archive sitting on a publicly accessible Cloudflare R2 storage bucket.
Unobfuscated, so just completely bare for the world to see.
Totally bare. And the scale of the exposure was monumental.
How big are we talking?
Researchers found approximately 1,900 files containing over 512,000 lines of proprietary code.
500,000 lines.
Yes. It detailed the agent's internal architecture, its telemetry gathering, its tool libraries, system prompts, and crucially, its context management logic.
Okay, let's pause on that term context management because that shows up constantly in the source material we reviewed.
It's a really big deal.
What does exposing the context management actually reveal to an attacker?
Well, context management dictates how the AI agent decides what information is relevant enough to keep in its immediate working memory and what it should just discard as it processes a task.
Okay.
So, if an attacker can read the exact logic of how Claude Code processes files, they can engineer malicious files specifically designed to stick in that memory permanently.
Oh, I see.
Yeah, they can learn exactly how to format a prompt to trick the AI into prioritizing a harmful command over, say, a legitimate security warning.
So they literally get the blueprint for how the AI thinks and sorts data.
Exactly.
Now, the sources are very clear to point out that zero customer data, zero API keys, or model weights were exposed here.
Right. That is an important distinction. The actual neural network remained totally secure.
And Anthropic classified this really rapidly as a packaging mistake rather than a server breach.
Yeah, they were quick to clarify that.
But still, exposing 500,000 lines of proprietary architecture for an agent designed to autonomously execute code. I mean, that creates a cascading threat, doesn't it?
Oh, absolutely. Especially considering the identity of the company involved.
Right, let's talk about that irony.
Yeah, because Anthropic was founded in 2021 by a group of former OpenAI researchers. And the primary reason they split off to start their own company was a fundamental disagreement over safety.
Right.
They felt the industry was moving way too fast and prioritizing capability over alignment. So Anthropic built its entire $60 billion brand, positioning itself as the deeply cautious, safety-first alternative.
And that context makes the irony of a massive code leak almost painful to watch.
It really does, and the enterprise market certainly reacted to it.
Yeah, because Claude Code is deeply integrated into the workflows of thousands of developers at this point.
Exactly. When the exposure hit the news, our business analysis sources show that several large organizations immediately paused their Claude Code deployments pending internal reviews.
Which makes sense. I mean, if you are running a massive continuous integration pipeline, relying on these agents to automate your software testing, what is the actual systemic risk of using a compromised agent?
Well, in those enterprise environments, the AI agent often operates with elevated privileges.
Okay.
It needs those permissions to compile code, access staging servers, push updates, things like that.
Right. It needs the keys to the castle to do its job.
Exactly. So if a malicious actor understands the agent's internal tooling because they literally downloaded the leaked source code, they might find a way to manipulate the agent
Into doing what?
into approving unauthorized code changes or maybe opening back doors in the enterprise's software.
Oh, wow.
Yeah, so the panic was entirely justified. An exposed agent at the core of a development pipeline introduces vulnerabilities at a massive scale.
Meanwhile, while the enterprises hit the brakes, Anthropic's competitors were basically handed a massive windfall.
Oh, an absolute gift.
Right. The engineering teams behind Google, Gemini Code Assist, GitHub Copilot, and just numerous open-source startups suddenly had free, unrestricted access to study exactly how Anthropic handles permissions and structures its toolsets.
Yeah, and Anthropic moved to mitigate that by issuing DMCA copyright takedown notices to GitHub and other platforms.
Okay, here's where it gets really interesting.
Yeah.
Because I want to push back on that strategy based on what we are seeing in the security community's response.
Fair enough.
Applying copyright law to a security incident feels highly problematic.
It is definitely controversial.
Right. I mean, if the code is already mirrored across hundreds of open source repositories, doesn't issuing a DMCA takedown just draw a massive spotlight to the architectural vulnerabilities? It's like trying to put toothpaste back into the tube with a lawsuit.
That's exactly the debate. It absolutely creates a rift between corporate legal strategy and open source security principles.
Yeah.
By utilizing DMCA takedowns, Anthropic is legally protecting its intellectual property. That is their right.
Sure.
But the tension arises because independent security researchers argue that utilizing copyright to scrub a leak obscures flaws that the community is actively trying to patch.
Right. It's security by obscurity.
Exactly. The argument is that preventing people from openly analyzing the architecture means the bad actors who, routinely ignore DMCA notices anyway are the only ones quietly studying the vulnerabilities.
And those independent researchers were definitely looking for vulnerabilities the second this dropped.
Oh, immediately.
They started dissecting how this agent interacts with a user's operating system. Because Claude Code isn't just a chatbot generating text in a web browser.
No, not at all.
It is highly agentic. It operates inside a developer's terminal, reading local files and executing shell commands.
And to secure that level of access, Anthropic built a permission-based architecture relying on a fail-closed philosophy.
Okay, what does that mean in practice?
They categorized operations into three distinct tiers. First, the allow tier. This handles pre-approved safe actions like reading a simple text file.
Makes sense.
Then there's the ask tier. This pauses the agent and prompts the human user for explicit confirmation before doing something potentially risky, like running a network request.
Okay.
And finally, the deny tier. This serves as a hard block on specific, highly dangerous commands.
They also implemented OS-level sandboxing, right? I saw they were utilizing tools like Bubble Wrap on Linux systems and Seatbelt on Mac OS.
Yes.
How do those specific tools actually contain an AI process?
Think of Bubble Wrap and Seatbelt as rigid digital quarantine zones.
Okay.
When the AI process initiates, the sandbox strips away all of its default operating system privileges.
So it's kind of flying blind.
Pretty much. The AI cannot see the rest of your file system, it cannot access your hardware components, and it is totally blocked from opening random network ports.
Oh, that's smart.
Yeah, it is confined to a virtual padded room and must explicitly request permission to reach outside of it. Furthermore, Anthropic hard-coded blocks against common data exfiltration tools like curl and regget, just to prevent the AI from sending data to external servers, even if it tried.
So they built a very robust perimeter.
Very robust, on paper at least.
Right. But in early April, just days after the leak, a security firm named Adversa AI found a crack in that perimeter.
They did. And it all revolved around a single variable they uncovered in the source code.
Right. It was called max subcommands for security check equals 50.
Yes.
What exactly is happening with this limit?
So to prevent the AI from freezing up, exhausting memory or getting caught in an infinite loop during complex operations, the system enforces a hard cap on its validation process. It will run its automated security validation checking against those deny lists and sandbox restrictions on only the first 50 subcommands of any given task.
Okay, wait. Let's use an analogy here to make this bypass memorable.
Go for it.
Think of this automated security check like a bouncer at a highly exclusive nightclub.
Okay, I like that.
Right. The bouncer meticulously checks the ID of person 1, person 2, person 3.
Doing their job perfectly.
Exactly. But the bouncer has this bizarre, hard-coded directive. After checking 50 people in a row, they are told to just get exhausted, throw their hands up, and just stop checking IDs and let anyone else walk straight through the door.
Yep, that's exactly how it worked.
So if I am a malicious actor, what stops me from just giving the AI 51 commands? Does the system crash, or does it do something worse?
Adversa AI tested that exact scenario, and the system does something much worse.
Oh, boy.
Yeah. The attacker crafts an exploit using a file named claudead.md.
Okay, what is that file?
This is a standard configuration file that developers use to give the AI context about a specific project folder.
Got it.
So the attacker creates a poisoned version of this file, instructing the AI to autonomously execute a sequence of 50 no-op commands.
Meaning no operation, just literally instructing the system to do absolutely nothing 50 times sequentially.
Exactly. So the AI processes the commands. The security system evaluates all 50, determines that doing nothing is entirely harmless, and approves them.
Right.
The internal counter hits 50, and the automated security validation shuts off to conserve resources.
Just like the bouncer throwing his hands up.
Exactly. And then the system encounters the 51st command.
And because the bouncer has stopped checking IDs, that 51st person walking in can just be carrying a sledgehammer.
Basically, yes. The 51st command can be a prohibited curl command.
Wait, but you said curl was on the deny list earlier?
It is explicitly on the deny list, but the system is no longer checking the list.
Oh my God.
So that 51st command executes silently, gathering your SSH keys, your cloud environment variables, your personal credentials.
And just sends them away.
Right, sending them directly to an external server controlled by the attacker.
That is deeply unsettling, because it completely bypasses the prompt context window.
And
the user wouldn't even see the agent writing malicious code on their screen, because the claudead.md file triggers the behavior autonomously in the background.
Right. And this highlights a fundamental flaw in the engineering logic. This vulnerability is a classic fail-open scenario.
Fail-open?
Yeah. When the security system hit its maximum limit of 50, it defaulted to allowing the next action.
Which is bad.
Very bad. A secure system must fail closed. If it hits a limit or encounters an unexpected error, it should halt the entire process, block all traffic, and throw an error message.
Right.
Failing open when dealing with an agentic AI that shares the developer's exact access privileges is just a recipe for disaster.
Because if this AI is running on your machine, it is operating under your user profile.
Exactly.
If it gets compromised, the attacker has everything you have.
Yep.
And this wasn't just some, theoretical exercise isolated to white hat hackers in a lab somewhere. Threat actors were parsing this leak in real time alongside the researchers.
Within days, major security firms like Zscaler observed active exploitation attempts in the wild.
What were they doing?
Attackers began setting up Trojanized repositories on platforms like GitHub.
Really? Just baiting people.
Exactly. They would upload these incredibly useful, well-written code libraries that developers would genuinely want to use. But they would bury a poisoned clolu.md file deep within the directory structure.
And there were also phishing campaigns using Claude Code security updates as lures, right?
Yeah, and social engineering attacks directly targeting Claude Code users. The ecosystem got incredibly hostile very quickly.
So what does this all mean for the listener? I mean, if you're a developer running one of these AI tools on your laptop right now, you might be thinking, well, I only use it for simple scripts or side projects. How bad could it be?
The answer is very bad.
Right. The entire threat model has completely inverted. It used to be that the primary danger of AI was that it might, write a buggy function or hallucinate an incorrect historical fact.
Right.
Now, simply cloning a random open source project from the internet and letting your AI assistant read the files can actively weaponize your own computer against you.
The attack surface is just unrecognizable compared to traditional software development. We are no longer just defending against malware executables or simple phishing links.
We have a whole new list of problems.
Yeah, we have to secure against prompt injection, where invisible text tricks the AI into changing its directives.
Right.
We have context manipulation, where malicious files rewrite the AI's understanding of a project. And of course, permission bypasses like that 50-command flaw we just explored.
Which is terrifying.
It really is.
Okay.
The consensus across all the incident reports we reviewed is that agentic AI tools must now be treated as critical infrastructure.
Now, to be fair, Anthropic did release version 2.1.90 to patch this specific command limit flaw shortly after it was disclosed.
They did patch it quickly, yes.
But the structural reality of the threat remains. This entire sequence of events is a massive wake-up call for the industry.
A huge one.
We went from a single omitted .np minor file to a 59-megabyte leak that laid bare a $60 billion architecture, revealing a completely mundane loop limit that essentially handed full system access to anyone who could count to 51.
It really reinforces the urgent need for standardized security auditing frameworks specific to agentic AI.
Right.
The blast radius of an AI vulnerability grows proportionally with the level of autonomy we grant the model. We cannot treat AI assistants like standard text editors or simple productivity boosters anymore.
Let's push that thought a bit further before we wrap up today.
Okay.
The sources focus heavily on developing new auditing frameworks and patching these existing permission structures.
Or as standard fixes.
But if these AI agents are essentially acting as autonomous pair programmers operating with our level of access, reading our local files, executing our terminal commands, maybe the future of AI safety isn't just about constraining the AI's brain with better system prompts and arbitrary command limits.
Where are you going with this?
Well, if an AI acts like a human peer, perhaps it requires an entirely new, heavily restricted virtual workstation to operate within.
Oh, interesting.
We might need a completely new operating system built from the ground up just for agents, rather than trying to patch them into our own sensitive, inherently vulnerable developer environments.
A structural shift in how we isolate compute environments might inevitably be the only way to safely integrate these tools moving forward.
It's definitely something for you to mull over the next time you give an AI blanket permission to analyze your local files.
Definitely.
Just remember, you can spend billions building the most advanced vault in the world, but it won't matter at all if you leave the blueprints taped to the front door. Thanks for taking this deep dive with us today.